Good morning. So today is probably one of the more important lessons in this topic, and we look at something called the line of best fit. So let's get straight into it. I will add also, you may or may not be able to hear a very slight piano noise, and they say that this can help the lesson be more soothing. So here I am explaining the line of best fit. If it is annoying, I do apologise, and comment below for some feedback on the piano sounds. However, the line of best fit, there is basically, to dumb it down the most I can, a very basic way of drawing a line of best fit, and it's not the most accurate, but it works for some extent. But then there's a very accurate way of drawing it. Okay, so let's look at the more basic way to start with. And we say that we do this way by eye. So first of all, what is a line of best fit? A line of best fit is where you can draw a line through your scatter plot if it has a certain trend. Okay, so this line is basically the most accurate line you could possibly draw to show that trend. Okay, so think about the equation of the line, thinking about the slope of it, where it starts and stops. And the idea is you want it to be as accurate as possible to be able to then predict different trends in the future, past the graph, what is going to happen. So you can see this first example here. We've got a scatter plot, and I've drawn through it the red, and it's a rough trend. Now, there's one important thing when you are drawing a line of best fit by eye. And it's that you need to have the same amount of dots above and below the line, okay? So sometimes it's not always possible, okay? And when I say that, it means if there's big outliers or a huge cluster, sometimes your line will go through dots. But the idea is you want to draw a line that has, as best as you can, the same amount of dots above and below. So you can see here that my scatter plot, I have filled in this line of best fit as best as I can, putting it in that scatter plot where there are 7 dots above and 7 dots below. This line of best fit now allows me to predict the trend for the future, okay? So for instance, if they asked me what the value of, what kind of prediction I'd be looking at, that's extending past the graph, I could use that line of best fit. Okay, so one example let's do together. If you find that pretty basic, that idea, pause the video and give this example a go on your own, okay? But otherwise, this example, we've got a table. It has the number of people using a swimming pool over 8 days in summer, and the temperature, okay? So you've got your dependent being your number of people and your independent variable is the temperature, okay? So the number of people is depending on the temperature. All right, it wants us to draw a scatter plot, then draw a line of best fit by eye, and then look at the association between it. So again, pause the video and I'm going to do the same, and I'm going to draw my scatter plot. Now, before you do that though, thinking about your scale, okay? So your temperature is going to be on your x-axis, okay? And it's ranging from, what are we looking at, 20 up to 36, so you might just go from 20 to 40. And then the number of people is ranging from, what have we got, 280 up to 500, okay? So you might go from 280 up to 500, or you might just go 250 to 550. It's up to you, all right? Okay, pausing the video now to do my scatter plot. Okay, so I've put this grid on, done my axes. Again, if your axis is going up by a certain amount that's different to mine, that's okay, as long as each axis, being your x and your y, are going up by the same amount on their own axes. Okay, now something you do sometimes see, and you usually see it in science a bit more, is some symbol that kind of looks like that. And what that means is I'm not starting at 0, okay? According to the syllabus, they don't mention anything about it, so it's not a necessity, but it's something you can show just to show that you have a bit more knowledge. Okay, I'm going to continue to put my points on now. Okay, and there we have it, my scatter plot. okay? I put my points on as accurately possible. There is looking like there's quite a, I don't know, we could say strong, yeah, I'd say strong trend, particularly because I'm quite zoomed in as well. Imagine if I was zoomed out. Now when I say that is, if I did go from 0 to 100 on the temperature axis and 0 to 1,000, you would literally see a very strong trend. I'm quite zoomed in, remember that, okay? So I would call this a strong trend. But we could work that out from yesterday's lesson, Pearson's correlation coefficient, and find out ourselves by a certain decimal place how strong this trend is. Anyway, now we want to draw a line of best fit by eye, okay? Now there's 8 points, which means by eye I'd like to have 4 above and 4 below, okay? Not always the most possible thing, but I'm going to try as best as I can. Okay, here I go. Let's put a shape in. Okay, it's looking as though it's probably going to be, why am I? Now I can adjust it because I'm lucky enough to be able to draw this on a device. And there I have it. My line of best fit, okay? I'll make it a bit thicker. Again, 4 above, 4 below. Now, you can see the restrictions to doing it by eye because everyone's graph is technically going to be slightly different. Okay, yours could have been on a bit more of a slope. It's going to be roughly the same, but there is room for error. All right, now we're going back up to these questions. We've drawn our line of best fit. Is there an association, positive or negative? We can say, yep, definitely there is a positive association. I would say it is a strong association. And now it says use the line of best fit to predict the swimming pool attendance where there's a maximum temperature of 18 degrees. So this is the best part about it now. This is why we do a line of best fit, because now I can say, okay, 18 degrees, I'm going to say, well, if I'm going up by 2 is right on this point here. And I'm looking at about there, okay, which these are going up and down by 20. So it's probably going to be around 260 on my graph. Now yours could be slightly different again, okay? All right, a 30-degree day, I'm going to go, okay, coming up here along my 30-degree line. It's looking like it's going to be, according to my graph, around 400. Now in a HSC, they're obviously going to be lenient on your answer to an extent because they know most people's graphs are going to be slightly different. And 40-degree day, you can see by my graph here, it's coming up this line, it's hitting here, which I know it's going to be 520 on the next one, so 510, so maybe about 515. So that's the whole point of this trend line. What a great tool, okay? And relevant. Now, think about today, right? We're looking at the trends in the coronavirus pandemic. It's not a straight line, we know that, that's why they're calling it a curve, okay? It's an exponential, but they are using these same mathematical tools to predict what it's going to be in the future. What a coincidence, we're doing that right now. Okay, so let's go to the really accurate way of drawing our line of best fit, and we call it the least squares line of best fit, otherwise known as the least squares regression line. You can also see it somewhere, but it's basically, it's way more accurate than just doing it by eye, and everyone's going to get the same, okay, which is, in my opinion, what they're going to ask more of in the HSC, because markers don't want a whole bunch of different answers. They want everyone to have the same. It's much easier to mark. So be prepared to be able to have to calculate these. So here I've got a new set of data. It wants me to draw a scatter plot, then do the sketch of line of best fit with your eye. So I want you to pause this video right now and now do this one on your own according to everything we just did above. What you can't do just yet is part 3 though, because that's the new part, okay? So pause now and do part 1 and 2. All right, there I have it. Now, again, I'm quite zoomed in because I've gone up as accurately as I can over that entire space. And the smaller your gap is between the values, the more accurate you can see all the dots and draw this line of best fit. I mean, you start to run into trouble if you do your scale too big, right, over a large amount of numbers. the dots all become very close together and it's harder to do your line of best fit. So my best advice is to always try and be right near the minimum and maximum value on your scale, if that makes sense. Again, your line of best fit is going to be different, but the idea is 4 above, 4 below, because there was 8 in total. All right, now we look into our least squares line, okay? And so now we're going to draw a line of best fit using our least squares line of best fit method. So it's a new method, all right? And the idea is, why is it called least squares? Well, they created this formula, okay? And this formula is basically saying, well, look at this line of best fit, right? They said, okay, if I draw a line from every dot up to down to my line of best fit. The idea is you'd want the smallest distance as possible from all of them. So it's talking about, well, how could I, maneuver this line of best fit so the sum of all of them differences are the exact same, okay? And they went a bit more accurately and said, okay, well, if I make these all squares, so it's kind of like an area, then they said, okay, well, what would be the smallest area I could have in squares if, and then some of these are going to overlap, if they're all squares, and hence why it's called least line regression of least squares, you know what it's called. So it's saying about these areas, what is the smallest possible total area that you could have, and that's what the most accurate line of best fit is, okay? The ones that has the smallest area. I like to just put it more plain and simple and just think about those vertical distances rather than the area itself. It's the same idea. So where can I put that line so that all those distances are their smallest? And that's what this is. So it's using your calculator. Really, it's this massive big, well, it's not massive, but it's this formula that you don't need to know how to use, okay? It's not in the syllabus to know the formula, but it is in the syllabus to know how to input it into your calculator. Now, what I have created, and it is posted on our class compass, is this. If you watched yesterday's video on YouTube of Pearson's correlation coefficient, it's nearly the exact same calculated process. So if you got that down pat, looking at this now is not going to be much different. You do every single thing all the way until you get to, so you press mode, to statistics, then you press that button, you enter all your data in, clear it, press shift 1, press 5, okay? Then it's from that step, which I'll make that block a bit thicker, it's from that step onwards is where it's slightly different. So what you're going to do is put all your data in, press these buttons, and then you're going to press the 1A. Okay, what that tells you is your y-intercept. Now, quite confusingly, we know our equation of a straight line is y equals mx plus b, right? Or plus c, we've seen it. Where m is your gradient, b is your y-intercept. So what they have just used this time is slightly different letters, which is quite frustrating, I know. They've actually used bx plus a. How confusing. And that's just very frustrating, but that's how it is. So what you need to remember is when you press 2b on your calculator, that's going to give you your gradient, okay? Then when you press your 1a on your calculator, that's going to give you the y-intercept. Then that's going to give you the equation of the line of best fit, okay? So it's all calculator work. You enter the data, press those buttons, it's going to give it to you. If you're not sure, I can make a YouTube video, so request it below on the comments, or just type into YouTube yourself, equation of least squares line of best fit, and there'll be somebody with a Casio calculator doing that example, okay? So you put it all in and it gives you the equation of your line. Now, what do we do from there? We've got the equation of the line. We have a few options. You could plot all your points, you could do your intercepts and plot your intercepts, or pardon me, to draw any straight line, you only need 2 points, right? Because you can connect the 2 points and there you have it, okay? So just plot 2 points from a small table of values and join them together. All right, I'm going to put these values into my calculator and I will tell you what the equation should be, but otherwise you should practice too. All right, if you've put those in your calculator correctly, and me too, you would have got an answer that A is equal to 39.65, blah, 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 and B is that. So now I'm going to write that in my equation. So Y equals 5.2 decimal places, 35x, plus 39.65, okay? So there I have it, there should be a point in there. Now I just have to graph this line. Now, like I said, you only need 2 points. So all I'm gonna do is a quick table of values, and I would recommend just doing a table of values, don't overcomplicate it. I'm going to have my X here, my Y, okay? And I'm gonna pick some X values that are on my graph. All right, so I'm gonna go, let's go with 2.2, and you could do more than 2 points if you want it to be more accurate, but 2 points is all you need. And let's go, so 2.2, and let's go one up here somewhere, 3.2. Now, all I'm going to do is take those values there and sub them into where X is and put your answer underneath. Then take this value, sub it in where X is and put it underneath. Okay, so I've subbed those values into my calculator, I've plotted, I've found my Y value, and now I'm plotting them. I'll use a different color just so we don't get mixed up. Let's do green. Okay, so now just plotting these points. At 2.2, I'm at 51.42. So 2.2, I'm at 51 and just near halfway there. Then at 3.2, I'm at 56. So 3.2, I'm at 56, nearly 57. So now I can join those two together and find the equation of line of best fit. And now just join them together. Okay, so I will put my line on. Now, I'm a little bit out. Let's go. Getting closer. Again, with a ruler, it's going to make your life a bit easier. Okay, and there I have it. I will make that line a bit thicker. There we go, that'll do. All right, so I was pretty close. And again, the smaller your scale is, okay, on your X and Y axis, so the less you're going up by, the more zoomed in it'll be, so the more accurate you can draw your line of best fit by eye. And as you can see, I was pretty accurate. So that's the process, okay? So it was a lot to take in today. What I suggest is make a summary, all right? The idea is you can do it in two ways, by eye, same number of dots above, same number of dots below, or by the calculator, which will find you your gradient and your y-intercept. Then you just got to plot 2 points and graph it. I think we might spend 2 lessons on this just because it is quite important. So don't stress. Tomorrow's lesson I will maybe do some HSC questions or some other questions around this idea. So in terms of that, I will put the exercise questions on this lesson plan, but again, don't stress about doing them all today because tomorrow's lesson will help you for them as well.